Unit 3, Part 3 of 3.4. Geometric series. Right, let's just recap. This is still part of sigma notation. So sigma notation means you have to add a number of terms and there's some or other pattern to them. Now, for two of the kinds of patterns, we have short ways of adding them. In other words, a short rule for getting the answer without physically having to add them all. One way was if you, for each term to get the next term, you add the same number or you subtract the same number. Geometric series is the other one, is when you multiply each term by the same value to get the next term. So here's an example. Let's say p equals 1 up to 7 of 3 times 2 to the p minus 1. Right, can you see that the 3 is not to the power, only the 2. So when p is 1, that is 3 times 2 to the 0, plus 3 times 2 to the, if p is 2, 2 minus 1 is 1, plus the next value p is 3, so 3 minus 1 is 2. Let's do one more. 3 times 2 to the 3. And our last term will be 3 times 2 to the 7 minus 1, which is a 2 to the 6. Right, I'm going to work out the first 4 values. 2 to the 0 is a 1. So it is 3 times 1, which is 3. Then we've got 3 times 2, 3 times 4, 3 times 8. And I'm just going to say plus dot dot dot. Now, if you look at going from 3 to 6, you might think it's plus 3, but then from 6 to 12 is not plus 3. So go back and think again. Oh, how about multiply by 2? So now we don't have, so if I'm multiplying by something, it's geometric. We don't have a common difference. We have a common ratio, which we write as an R, and our common ratio is 2. Right, with these it was easy, but here's a little trick for if the ratio is quite hard to find. Your common ratio R is if you take any term, let's say the second term, and you divide it by the previous term, then you should get your common ratio. So 6 divided by 3 gives me 2. But it should this be the same all the time. So you'd also take the third term, 12 divided by 6, also gives you 2, etc. So if it's one that you can't see so easily, you'll use that rule. Right, what else do we know? We still have first term is called A, which is 3. How many terms? Top minus bottom plus 1, 7 terms. Right, now, so we're going to add 7 of these terms, but instead of adding them all, we have a rule. So your formula for adding so many terms when it's a geometric series, in other words, where you multiply, is more involved. Make sure you've got that formula. So Let's do it here. S7 equals 3 times 2 to the 7 minus 1 over 2 minus 1. Again, you can put it in your calculator. Just make sure you put it in correctly. It gives you 381. Right, let's do a slightly harder one just to show you these you can actually get quite, shall we say, ugly answers. I'm going to start at -2 and go up to 4, and it's a half times 3 to the 1 minus r. So that is a half times 3 to the 1 minus 2, so 1 plus 2, plus a half times 3 to the 1 minus 1, plus, I'm going into myself here, right? A half times 3 to the 1, plus, let me do one more, a half times 3 to the 0. That's not my last one, so I must remember to put plus ... to show that I know it keeps going. I'm just not going to write them all. Right, you can work out each particular value on your calculator. It is just to get the first, it's good to have 4 of them in a row so that you can make sure your pattern is correct. And now we're going to do that method because here my R is quite tricky. So I'm going to do T2 divide by T1. In other words, 9 over 2 divide by 27 over 2. Remember your fraction rules. It gives you 1/3. So your R is now a fraction. What is my A? It's my first term, 27 over 2. What is my N? How many? 4 minus 2 plus 1, which gives me 7. So 7 terms again. 27 over 2 times, now I've got to put the third in a bracket, to the 7 minus 1 over a third minus 1. And when you calculate that, you get 1093 all over 54. So often with these we will just give the decimal value and round it to 2 decimal places. So you can just give it like that. So with geometric, it is possible to get quite ugly answers. Let's just do one final little special one. If I have, for instance, I equals 1 to 10, but there's no I, the variable that I've got down here isn't in the number. There's only a constant. Then your rule is just 10 times 4 equals 40. So as many terms as I have times my constant, and that gives me my answer. So that's just a special one.